Hey everyone. Today I'm showing progress that I've made on my 3D engine for 3DO. I've named this engine Matinicus after the island in Killing Time. It's inspired by Killing Time, so I thought the name was appropriate. But I figured what I would do is showcase the visuals first, run through this new map to show some of the different things that I'm now supporting and high level of how it works. And then I'll get into more of the technical details, sort of behind the scenes of what's powering all this. So off the bat, you can see that I have some adjustments to lighting. It's pretty close to Killing Time, I would say. As we come this way, you'll see that I have stairs. Those are individual sectors that all have slightly different heights, and the player is essentially planted to the ground in whichever sector he's currently in. So that's how I'm able to create that effect right now of going up and down. I also support Mip Mapping, so I can give you a good visual of what that means. So a little background on this. I know in modern games when you perform Mip Mapping, textures at a distance can look a little better actually than textures that are closer. If you have high-res textures far away from the camera, it can look almost as if static parts of the world are moving or when you're walking around, and it can look a little strange. But Mip Mapping also helps with performance too. I don't think it's as huge of a deal these days for modern development, but back in the day for sure it was vital. And so what you're looking at here down this hallway is you're looking at the same texture all throughout on the walls, but there's different levels of definition that's being served, meaning the texture sizes are different. And that's really important for the cell engine, because the cell engine is going to process smaller images faster than larger images, especially when you're combining operations like scaling and rotating. It's all work that the cell engine has to do. So if you're feeding it less data, it's going to help it that much more. And so this texture right up front, this wall texture here, that is the highest definition that the engine is supporting, which is 64 pixels. So this particular one is 64 by 64. Way off in the distance there, if I point, this texture that's being served is 16 by 16. And as I get closer, you're going to see when it jumps to 32 by 32 right there. So that's a 32 by 32, then 64 by 64. So that's Mip Mapping. And I have it Mip Mapping for wall textures, ceiling textures, floor textures, and even sprite textures. With floors and ceilings, I was able to get by with an additional little trick. So instead of going from 64 to 32 to 16, I'm going from 64 to 32 to 8. So 8 is very small, and when it gets blown up, there's not much definition there at all, but it works because by the time this engine's serving an 8 by 8 scaled up texture for floor or ceiling, it's so far away, essentially way back here, and it's so dark that you don't notice if it's 8 by 8 or 16 by 16. The perspective hides it anyway with the light. And so walls are still more visible, so I couldn't pull that off for walls, but I save a little more processing time for the ceilings and the floors. So if we come this way, here I have some stairs that go down. I have some diagonal areas, so the map design is not limited to 90-degree angles, orthogonal. If I come back here, I have my sprite, which is also Mip Mapped, so you can see the textures changing actually. It looks like it's just getting a little blurry, but it's serving different textures. The lighting definitely helps cover up the loss in quality. It wouldn't look right at all without the lighting. You can see I have some pillars in here, which are my interior walls in this sector, and it's sorting properly. So the sprite's sorting against that, and these pillars are sorting against each other. By the way, the engine only needs to sort sectors when sectors have interior walls or sprites, or both. But most of the time, it doesn't have to do any sorting within a sector. This was the room that we started in, but if I go this way, you can see we have a high ceiling there, connects down here, and here you'll see, so this is new, you'll see that I have a wall here. It's not a big block like everywhere else that we were seeing, and it's not an interior wall either, that's a sector. So I'm now able to have sectors that have variable thicknesses to simulate walls in Killing Time or similar games. So now it would look appropriate to say have a door there. If you wanted an area that looked like a bunch of rooms, like Killing Time did sometimes, then you can now do that with this. This required me to rewrite most of the sector portion of my engine, to be honest. I realized early on that I made a mistake in how I was processing things, and this wasn't possible before. So I had to do a lot of rewriting. But now I'm able to do things like this, where I even have windows. So you can see window frames there. And if we come around to the back of that, you can see, I'm clipping through walls here, but you can see this is higher up. There's the window from the other side. If I leave the map, you can get a better idea of what the engine is processing at any given time. So even though the map is large, it's not processing everything, obviously. So let's take a look at what this map looks like in the actual editor. And actually, before I do that, let me explain these numbers up here on the top left. So this number up here on the far left represents the current frames per second that the engine is running at, and I have it locked to 30. The reason why I picked 30 is because that seemed to be a good average. It's unfortunate because sometimes it was hitting 40 plus, 50 plus, even 60 plus. But it would be very jarring trying to control movement and game logic when you have this frame rate just going crazy. So I've locked it down to 30. And when it dips, it usually dips to 29, 28. I believe there was one area in this map where on hardware it dropped to 25, but it was like one part depending on where you were looking, and it was building like some complex areas where the window was, and so it's not that common. There's still some room for optimization, but so far it's looking promising in terms of performance. This number on the right is the number of quads that are being rendered at the end of the frame. So ultimately this is what's being rastered. Now there's not a direct correlation. So having a higher number here doesn't necessarily mean we're going to dip. By the way, it keeps dipping to 29 here, but I think that's just like a routing issue. I'm pretty sure everything that I've been running through recently here is 30 or over. So I might have just a routing issue with my frame weighting or my the creation of that value that gets displayed on the screen. But anyway. So there's not a direct correlation between how many quads are being rendered and the frames per second. There's a lot that's happening, which we'll cover here in a second. But let's open up the map editor. And that's the wrong map. Let's open the right one. So this is the area that we were just running at. And if you look at the 3D view within Ultimate Doom Builder, you can see it's a pretty good representation of what we saw. Now within Ultimate Doom Builder, the editor, I'm not bothering with texture offsets to make sure everything lines up, because at the end of the day, it doesn't matter to my engine. My engine is not utilizing any sort of UV mapping from this editor. It has separate logic for texturing, so it doesn't really matter at the end of the day if I adjust the offsets of these textures in the editor or not. But this map is about as large as one loaded area at a time in Killing Time. Maybe it could be a little bigger, but I still have a lot of memory left to support that. So in Killing Time, you were always running around one area of the world at a time that was loaded, and it would seamlessly change into different maps or areas as you moved around the world. And so I'm already pretty much mimicking the first part of that. I don't have a way to swap levels out yet, but eventually that will come. And before I talk more about the sectors and how the engine knows what to process and all that stuff, I should maybe explain what sectors are a little better, or recap it if I've already covered it. Just to be safe, I'll cover it really quick. So each of these highlighted areas that you're seeing, these are considered sectors. And if you look in the top-down view, this is how you design levels in a Doom-style editor. You're designing in 2D. However, my engine is 3D. So even though you're designing in 2D, and you're creating this, what they call WAD data, the WAD file format for Doom, my data converter is going through and creating all the geometry from this in 3 dimensions. So each vertex, each point of my world geometry exists in 3-dimensional space. So 2D designed, but true 3D rendered in my engine. The problem with design in 2D, though, is you can't do fancier things like have room over rooms, because you're only designing along the X and Y plane, or X and Z. I guess you use that. You're not really designing up or down, except for changing sector attributes. But going back to sectors, so sectors can have wall textures like this. It can have a ceiling and floor textures. It can have interior line definitions, which will create walls. So all these lines are called line definitions. And some of these are single line definitions, like these outer lines. They don't connect to anything else. This line right here, this line connects to another sector. So it's a 2-sided line definition. It doesn't have any geometry. It doesn't have any textures. It just serves to represent, hey, there is a seam here connecting 2 sectors together. You can also use this later for logic. Like, let's say you pass by a certain 2-sided line definition. Maybe that triggers some monsters to, open up a hatch or something. You could do things like that. But, so these are the line definitions of the sector. And a sector can also have a floor height and ceiling height. And that's how you create stairs. So if we come over here, these are all sectors. And each of these sectors has a different height, floor height, and ceiling height. And you'll notice that when you have areas that have different heights like this, you also have new textures you got to support. So these are like the upper textures. This would be like a lower texture. So if I click here, you can see upper, lower, and there's no middle because it's open. But okay, so with that covered, let me also show you the Skybox support that I did before we get into the weeds. Wrong one. So this is another map. There's still some more work that I need to do to combine skyboxes with more complex maps like the last one. So that's why I created this smaller map to do testing with skyboxes. What my engine will do is if I have a wall texture that's missing or a ceiling texture that's missing, my converter is going to assume that you meant to have it be invisible, or basically to not have any geometry there. So that's how we're able to create windows to other rooms, or in this case, you're going to see windows to the exterior. So if I build from this map, and if I enable my Skybox in my engine, this is just a macro that updates my engine flags to enable or disable things. So in this case, the Skybox. You will see the same Skybox used in Killing Time in the beginning area in the courtyard for 3DO. And here it is. So I have a bigger window over here. You can get a better look. And I have parallax scrolling going on. So the horizon there, the sky and the water, that is rotating slower than the trees. So you can see that there. And those are the killing time assets that I've been practicing with. And by looking at their assets, I was able to figure out how they did it, how they implemented it. It's not just one big image. That wouldn't be very good, because it would basically have to be at least twice the size of the resolution of the screen. And imagine you rotate this way, and now you have 320 plus pixels that are off screen trying to be processed by the cell engine. Like, that wouldn't be a good idea. And so this Skybox is being composed of, I believe, 5 cells, if I remember correctly, that are stitched together. And so depending on the angle you're facing, it figures out basically where the first one should be, and then it stitches the rest, or chains the rest together. And if any pixels are off screen, it's not going to be much. At most, right? It's going to be about half of one of those cells. And so that's better overall for performance. What's also cool about this room is I have like these steps up here, a platform looking down into the room below. So you're able to create some pretty interesting little level designs. You'll notice that on the ceiling, you have there's some gaps here. So I have probably some rounding issues with the 3D transformations that I got to look at. And right now, if I try putting a skybox in a larger map, it'll cause a problem when a sector becomes too far to render. And you'll see blackness because of the lighting, but then you'll see the skybox sticking through. So there's still some work that I need to do to make this proper. But with that said, we can dig into some of the technical details that makes this all work. Let's see here. So I had a list of things that I was going to talk about. We talked about the frame lock. Find sector. So we talked about a little more about what sectors are. The player is always going to be inside of one unless the player is moving around outside of the map. But I needed a way to find the sector that the player was in, because that plays a huge role in the portals, the portal system that I'm going to explain here in a second. And so find a thing, this just finds the thing. So in Doom terminology, things are like the player, the enemies, the health, all the entities. So I just kept that terminology here. So we find a thing, we find the player. Now the engine has a reference to the player. And a thing has a last known sector. It's the last place the engine was aware the player or the thing was at. And so find sector will just, it will run very fast or somewhat fast depending on if the thing has already been found once. So when the engine's first starting up and it calls us for the first time, it's going to branch off and have to check every sector. So we'll see here, if thing last known sector is less than 0, that basically means we don't have any information whatsoever about where this thing might be. It's going to have to loop through all the sectors in the map and check, are you inside of the sector, yes or no? And it does that by just checking if a point is in or outside of a sector, which is like you could think of a bounding box that defines the sector. And the point is just where the player is in the XZ plane. So height doesn't matter. And when it finds a sector, it stores the index and returns. But the next time this is called, it will be quicker because it will know the last sector you were in. So it will grab a reference to that sector. It will then check if you're still in there, which is a quicker check. Most of the time you will be still in that sector. And it's done. However, if you're no longer in that sector, it only needs to check its neighbors. So kind of going back to the line definition, if we were, say, up here, It knew we were in this sector before, but we're not in here now. Well, we can either be here in this sector or here. So there's two-sided line definitions, which means there's joining sectors. It just checks these two sectors and then updates the last known sector. And that's very important information to have for the next step. So to describe the portal system, what I'm calling the portal system, I read how Duke Nukem worked a little bit at a high level and how it used something called portals. And I didn't see any code or anything, but just a high level understanding of what portals were, and I decided to implement that. So this batch nearby sectors is my portal scanner, if you will. So to describe what this is, I can use my little Microsoft Paint. But let's say this is a sector, this is a sector, that's a sector, and then you have one down here, and maybe you have another one over here, and one up here. And let's say the player is standing here. Well, we know where the player is, thanks to that find sector code. So it's going to do a sweep. It's going to check this sector and batch it for processing. It's going to go here, batch it for processing. It's going to come up here, add this one. It's going to add this one. It's going to add this one. And so it stops when a sector gets too far away. So you can think of my portal system as you have all these sectors that are connected to each other. You're somewhere in this world. It's going to scan outward and grab all the connecting neighboring sectors up to a certain distance from the player. And those are going to be all the sectors that are candidates for further processing and potential rasterization. So the distance check, let's say there was a sector here connected to this one, but it was too far away. You know, the recursion stops here. Same thing with here. Let's say there was a sector down here. This does not get checked because it's too far away. So you can imagine these red lines as being distances between the different sectors and the player. Now, to help speed this up a bit, I'm not using precise distance in units of accurate measure. I'm simply just taking a squared distance. So no square roots are happening. And I can't use, unfortunately, I can't just use one distance. I can't use, like, say, the center, which is something I recently fixed. The problem with just taking one distance from the center of a sector is sectors might get skipped prematurely. So let's say you have two sectors here, and let's just say these are very long sectors. And the player is standing, say, right here. Well, the distance between this center to here is a lot greater than, let's just say, this corner to the player. And so this distance might be greater than what the frustum, or the viewing frustum far plane is accepting. And so you may have a sector that disappears before the engine even has a chance to taper the view off with lighting. So in order to get around this, what I'm doing is I'm creating a bounding box, an axis-aligned bounding box around my sectors. You can imagine as this being these bounding boxes. And it doesn't matter if the sector is diagonal or a different shape. It still creates an axis-aligned bounding box. So let's say you have like a sector that looks like this. For simplicity's sake, it's still just going to create an axis-aligned bounding box like this. And it uses the four corners to check the distances rather than the centers. And the issues I was having before are now gone. The problem is now it has to do more checks. But the good thing is that if it finds that a corner is close enough, it stops. It doesn't bother checking the rest. So it's not too bad. So batch nearby sectors is recursive. It comes in here for each sector that gets analyzed. It gets marked so that it doesn't get rechecked in the same frame. If you have sectors that are, because you have sectors that connect back to each other, or portals that connect back to each other, so you don't want the same sector or portal to be checked again. So sectors get marked. These are the four corners that we were just discussing. For each of the four corners, it just uses a square distance to see if it's below that threshold. You can play with this value to try and increase the performance a little more, but I think I found a good medium there, a middle ground rather. And then finally, I do store the center distance because it's helpful for other things later. I may just try to take an average actually and save some square operations. But anyways, that center distance ultimately gets used when portals are sorted, but I'll cover that in a second. And then render sectors is just a list of sectors that are going to be further analyzed. So if you're running around that big map, there's probably 4 sectors that are part of that list, depending on how you subdivided things, depending if you're near stairs or things like that. And then for each sector's line, for each line definition in a sector, it checks to see if there's a 2-sided line definition, because that means it's a portal to another sector. If that occurs, it recurses through here again using the new sector, so it's recursive. But this runs fairly fast. I haven't noticed any issues with this really. I thought it would be a problem initially, but actually drawing cells is more time consuming than this. So if we go back, okay, so after we build up the candidates, the sectors for processing, update scene runs, which will update the view matrix. And I think I talked about this a little before, but this represents the translation of the camera, where the camera is, or the inverse of that, and the inverse of where the camera is looking, because everything is inverted. So for example, if you're moving forward, the world's moving back, right? If you're turning to the right, the world's rotating around the left. And so I'm using the inverse of everything. This rotation, by the way, these are 2 matrices. They're 4x4s. This rotation matrix represents just rotating about the y-axis. So that simulates the looking right and looking left. I could add additional rotations. In fact, I was doing tests earlier with this rotation matrix around the x-plane. So the x-plane would look up or down. And I could also do rotations around the z to tilt. And I think what I'm going to do in the final parts of this engine is implement a peak feature. So you can go up to a corner, peak, and maybe if you peak, there's a 50% chance maybe an enemy won't see you for about a second. So if you peeked real quick, you might know where an enemy is without actually having them see you. So that could be interesting. But right now this is just rotating about the y-axis for turning. And by the way, this is also something the Doom engine can do. I don't believe it can support any type of rotation like this outside of just looking left and right. But it creates this ultimate view matrix from the translation and the rotation, and this view matrix ultimately is what's going to transform all the geometry to camera space. So after the view matrix is updated, it calls sort portal. So remember that by the time this runs, all of the sectors around you have already been batched. And so it's going to loop through just that subset of sectors, only those. And it's going to sort them far to near, with the sector that you're in being the last sector to be rastered. So it is doing the painter's algorithm as opposed to figuring out what to render from the inside out, like Doom would do with the BSP tree. There's some benefits by not having the BSP tree. One of them is you could do some pretty interesting effects. For example, this may sound a little like Tomb Raider, but imagine you're in a room and maybe there's a puzzle that you solve. And then when you solve the puzzle, the room rotates, maybe locks you down so you don't run around, but the room will rotate, and then it will expose a hallway that you didn't see before, maybe a new opening. Maybe the opening you came into will rotate, and then you'll see a new opening, something like that Resident Evil probably do. But you can't do that with Doom technology or Doom engine, because you would have to completely rebuild the BSP tree at runtime, which you can't do definitely not on older hardware and runtime, because it relies on this baked information of the tree. While with portals, you're not limited to that. You can move portals around. You can rotate portals around. You're only limited by the transformations you're able to do on that hardware, how fast you can get those transformations done, which should be okay, because they're being transformed anyway. All you'd be doing is updating their positions, and then letting the engine take care of the rest frame by frame. So it should be doable. So there are some benefits. Also, I was thinking about using a BSP tree early on, but I couldn't wrap my head around how to even make that work while drawing nothing but quads for everything, including the ceiling and the floor. Like, I know when Doom was doing its rendering, it would figure out the walls, where the walls would be, and then it would create what they called the viz planes, which was up and down, and it would fill those gaps with like these linear pixel runs, and it knew when to stop, because it kept track of a buffer, where it knew when to stop traversing the tree from the inside out and when to stop rastering and everything. I couldn't wrap my head around using a BSP tree for this type of engine, but I would love to, if someone has an idea, just out of curiosity, even though I'm not using a BSP tree, I would love to know how to retrofit something like that. Well, just drawing pure quads for literally every single thing in this engine. But anyway, so there are some benefits. This sorting is pretty fast. There are faster sorting algorithms that I can play with later, but I did notice that when I was doing some profiling, this wasn't an issue, and mainly because it's not sorting a lot. A small handful of sorts and it's done. Sometimes it may not even need to sort much, because it depends on the point of view and all of that stuff. But so portals get sorted. The portals that are ready for processing get sorted. And then for each of those sectors or portals that are going to be rastered, it will go ahead and it will use the view matrix to create the camera vertices for all the sectors' world vertices. So this is the transformation part. Now, this is a batch operation, so it's going to process all of these vertices. It's not going to process all the vertices at once, but I only have to call this once, and the code is going to go through and process all the vertices linearly for me without me having to call this multiple times. But I do have to call this for each sector. So if it's processing, say, 5 sectors, it's going to have to call this batch operation 5 times. But I've noticed that it's not a problem. It only becomes a problem if you're calling this repeatedly for like every point, every vertex. But if you're already batching this stuff, calling it a handful of times, I didn't notice a difference in performance. Call sector. So the main difference between the old call sector and the new one is I'm no longer backface calling on my own. I'm using the cell engine to backface call for me. And the con to that is it's doing operations in the pipeline on quads that may ultimately get called by the cell engine anyway. But I found that for this application, it was still faster to let the cell engine do it than have me do it. So before, like I was creating these vectors and I was checking to see, the dot product and all that, and while the cell engine already has a flag you can set, or actually technically you clear a bit in the CCB flags, and it will not render counterclockwise pixels. And so I believe I have that right. And so just letting the cell engine do it, in my case, ended up being faster. So now my call sector code will just go through the quads, initially assume, okay, this quad's going to be rendered. If it gets the center already using the camera space that's been calculated, it averages together. So it doesn't have to do any transformations here anymore. It then will check to see, is it too far? Is it beyond the far plane? Is it beneath the near plane? It checks to see if it's too far to the left, too far to the right, too high up, too low. And all of this is just using bit shifting, so it's very fast. Down here, however, if the quad is vertical, this will be true for walls and sprites. Then I have to worry about clipping to the camera. So it does do some clipping or clamping to make sure nothing goes behind the camera. Sector to screen, this will create the screen coordinates from the camera coordinates for each point, and it will also adjust the lighting. No divisions, just a multiplication and bit shifting. The lighting is a little rudimentary for now, but I can clean this up later. What's interesting about this is, so it's updating these values, these multipliers, and these values to divide by to create the intensity, the effect of the pixel that's going to be output from these cells. And it does this by updating the pixel control word on the CCB. And so by playing with these two values, one's called PMV, one's PDV, which is the multiplier and the divisor here, or the division. This is what you could use to update how bright or dark to transform these textures for my lighting. And so if you look at my lookup table, I have, it goes from 1, which is no change, to like 3/4 to half to 1/4. And I can also go brighter. So what I was thinking of doing was, when you say you fire a weapon, I can do this wave where maybe all the intensities increase slightly so that it creates like this flash. But that's later on. And then I have some sprite logic, which I think I'll cover another time, because I barely have sprites rendering and it's a little rudimentary for now. Also, I found a way to improve performance while also getting things in the right order within a sector. So like in the demo, when you saw the pillars, those pillar quads had to be sorted in that sector, along with the sprite, because there was a sprite in there. But if a sector doesn't have sprites in it, or if a sector doesn't have interior walls in it, no sector sorting happens at all. And so that helps the performance a lot. And when it has to sort, it only sorts what it needs to, because the engine's going to know the ceiling and the texture, or sorry, the ceiling and the floor, that's all processed in a batch. The walls are later, and the engine's going to know when the walls started, and the sprites come after that. So when it does need to do sector sorting, interior sector sorting, it's only going to do it on a subset of the sector data. It's not going to try doing everything, because there's no point in trying to sort everything. So even when this logic does run, it's only going to sort a handful of quads at a time. So it doesn't seem to be impacting much right now at all. Knock on wood. If the Skybox has been enabled, I update that. I might show this on a separate video later once I have that all working correctly. Link the rendering list. So the quads don't have cells. My rendering list does. And every frame, this list has to be linked depending on what's in view, what's going to be drawn. And so it's going to update that cell accordingly with the texture information. So this saves memory. I only have to worry about one data structure that has cells, not every quad. That'd be wasteful. But if you look in here, this is a little hard-coded here for now, but this is where it grabs the right texture for the Mip mapping, depending on the distance, which coincides with the light fall-off range. So if it's farthest, it's going to grab the least definition one. Here's mid-tier and the highest definition. And then here you can see where it uses information from the texture to update the renderable cell information. Fast map cell will take the screen coordinates that already got transformed and map that to the cell. And it uses the fixed point versions for sub-pixel accuracy. Yeah, and then just links everything together. And then if there is a skybox, that skybox becomes the first cell. Otherwise, it just renders whatever the cell engine put first, or sorry, whatever the game engine put first. FPS counter, frame locking logic. Yeah, so it's come a long way. I plan to continue working on this and sharing more in the future. I hope I explain things correctly. Some of this stuff for me is a little hard to explain, but if anyone has any questions, please leave a comment, and I'll gladly respond to that. There's probably some stuff here that I missed that you want to learn more about, and I'm happy to cover it. Or just let me know if you want more details on some of the stuff that I covered, or if anything was just unclear. But I hope this helps. I think I'm on the right track to making a decent little killing time style engine for 3DO, and I'm still optimistic about it. I do have an idea to increase the performance even further, but I haven't worked through that yet. But it entails being able to call entire sectors at a time first before getting to the actual sector itself. If I can do that, I think I might be able to lock this down, maybe 35 to 40 frames per second. We'll have to see, but there's still some wiggle room, I think, to make this run faster. So I still am learning as I go on what's working best for this, but I hope you've enjoyed this. Thank you for watching, and until next time.